Hello guys, so in this video we're going to learn about calculation functions, and we're going to integrate one of the famous functions which you are aware or might have come across. That's integrating square root of 1 plus x square. But here we're going to use an alternative approach. So let me show you the solution. So this is how it looks like. So integration of square root 1 plus x square is half times x times square root of 1 plus x square plus half log x plus square root 1 plus x square. So let's follow the usual approach. So usually students would do the trigonometric function substitution. How? So remember, this 1 plus x square inside the square root looks similar to 1 plus tan square theta secant square theta. So if we substitute x for tan theta and dx for secant square theta d theta, that's the differentiation of tan theta. This is what we are going to get. So square root of 1 plus tan square theta will be secant theta, and dx will become secant square d theta. So we're going to separate it into two terms. Okay, u and v. Let's call u and v. So remember, this tells us about integration by parts. So we're not going to solve the full integration by parts. I'm just telling you the approach. So this is a formula for integration by parts, and when you solve it, you get the value. So in the next step, we're going to use an alternative approach. Okay, let's do some different. So rather than doing the trigonometric, let's use hyperbolic functions. So what are hyperbolic functions? Now this might look like another complex region, but they're simple. So hyperbolic trigonometric functions are nothing. They are written in terms of exponential. So if sine h of x can be written as e raised to the power x minus e raised to the power minus x by 2, then simply the cos hx will be written as e raised to the power x plus e raised to the power minus x by 2. Now here, see, the cos h of x is simply the derivative of sine h of x. Now this has uncanny similarity with trigonometric, right? Where if you differentiate sine x, you'll get cos x as the answer. So similarly here, the differentiation of sine hx with respect to x will be cos hx. So here we have our trigonometric function. So we're going to do this in 10 steps. So step 1 will be substituting x with sine h of t. Okay, we also could have done cos h of t, but I'm using sine h of t. It's up to you. The step 2 is we're going to then differentiate dx by dt in order to change everything in terms of t, right? So dx will be cos h of t dt. So that will become this. Now here, the third step will be substitution. So here you're going to replace x by sine h of t. Now here you're also going to replace dx by cos h of t dt. But before going ahead, let's have a look at one important identity equation, which is same as we do in normal trigonometry. In hyperbolic function, cos square ht minus sine square ht is equal to 1. So here we're going to replace 1 plus sine square ht as cos square ht. So this is how this is going to look. After substituting, square root 1 plus sine square ht will become cos square ht. So square root of cos square ht times cos ht dt. So remember, here we have two cos functions. So finally this will look like cos square ht dt. So let's substitute hyperbolic function by the exponential function. So here, if I square both the sides, so this will look like this. So we are using the formula of a plus b whole square. So here I'm replacing cos hyperbolic function in terms of exponential. So we're going to put this thing in integration. That's step 7, and after that we're going to break these functions into different integrals. So this is how this is going to look. So here we're going to integrate 3 parts. Now remember, while integrating an exponential function, if it's e raised to power ky with respect to dy, the constant part will come in the denominator. So this is how it's going to look. In simple terms, e raised to power 2t by 4 will simply become, after integration, e raised to power 2t divided by 8. And this is how this is going to look. So in our 10th step, we found the final form as e raised to power 2t minus e raised to power minus 2t by 8 plus half of t. Now here, our main aim will be to convert from this form from t to x. So here we'll have to do pretty good amount of algebra. So let's switch to algebra. So our main motive will be to find the value of e raised by t as a function of x. So here we're going to square the x function. So after doing that, this is what we get as x square is this thing. So let's do some kind of algebra. Let's do x square plus 1. So I'll add 1 on both sides. So on the left side, it will become x square plus 1. On the right side, this will simply become 4 by 4, right? Since we want the common base in the denominator as 4. So after adding 1 on the right side, this will become 4 by 4. So this is how it will look. So there's a reason I'm doing, just bear with me. So once we have both the values for x square and x square plus 1, this is how this is going to look. Remember, doesn't this remind of you of the form of a minus b and a plus b? Now using this thing, I've cancelled out the squares, the power 2 on both the sides, and now we are left only with square roots. Okay, now if I call the function on the left side as 1 and the function on the right side as 2, now if I add 1 and 2, I'll be left with e raised by t. And if I subtract 1 from 2, it will simply become e raised by minus t. In other words, I've been successful to convert or express t e raised by t as a function of x. But remember, in the integral, it's asking about from e raised by 2t. So there's a squared function. And also, if I take anti-log on both the sides, I'll get the final value of t, irrespective of exponential. Now remember, in the previous step, here I have taken positive square root of x square and positive of x square plus 1. Why have I not taken negative? So here, remember, exponential always gives non-negative results. So if you add to exponential, it will always be greater than 0, right? As an example, if you do exponential raised to power 1 plus exponential raised to power minus 1, it's positive. Even if you do exponential raised to power 1 minus exponential raised to power minus 1, since the second term minus e raised to power minus 1 is smaller than e raised to power 1, no matter what, this is going to be positive. Hence, that's the reason, while taking the square root from here to here, I've taken it as positive x square and positive x square plus 1, not negative. So here, in the next step, we have found the value of e raised to power t, but we are yet to find the value of e raised to power 2t. So you're getting any links? That means in order to find e raised to power 2t, we are going to just square e raised to power t function. So this is how it's going to look. So we're going to square e raised to power t, and from this is how this is going to look. So we're going to use the equation of a plus b whole square. So using this property, we found the value of e raised to power 2t. Similarly, we'll find the value of e raised to power minus 2t using a minus b whole square. Now we have reached so far. I know this is a bit boring, just bear with me. Now, if in the integral function, we actually want to find the value of e raised to power 2t minus e raised to power minus 2t. So in order to do that, what we're going to do, we're going to do 3 minus 4. So when we do 3 minus 4, so 2x square plus 1, the positive terms cancels out, and we are left with negative terms. So 3 minus 4 becomes 4 times square root of x square into square root of x square plus 1. Now here we have found the value of t, and e to the power 2t minus e raised to power minus 2t. Now finally, when we substitute it into step 10, this is what we are left with. And this is exactly the same answer that we started initially. So this exercise we took just for fun, so that we can show you there's more than one way to skin a cat. So this was really fun and boring for some of you. So this was a good exercise. I have a gift for you. If you're looking for some of the practice questions in integration, I have made these questions. There's a total of 6 questions. Now, if you want some answers, you can contact me or write in the comments. I'll get back to you, or you can contact me personally. That's it, guys. Thanks for the time. Have a great day.